Let's break down the core idea behind this paper. Retrieval Augmented Generation from Facebook AI and University College London. In 5 minutes, you'll get the whole blueprint. How a language model learns to look things up before it answers, and why it became the default way to give a model knowledge it wasn't trained on. A language model is a closed book. Everything it knows was frozen into its weights the day training stopped. So when you ask it something, it just answers from memory and hopes it's right. Sometimes it makes things up, and it can never tell you where an answer came from. RAG's fix is almost embarrassingly simple. Give the model a library card. Before it answers, let it look things up in an external index of Wikipedia, then write the answer using what it actually found. Retrieval plus generation working together. Why does that matter so much? Because knowledge baked into the weights has 3 sharp problems. You can't update it. The world changes, but the weights don't, short of retraining the whole model. You can't inspect it. There's no page number, no source, so you can't check whether it's telling the truth. And it hallucinates. When a fact isn't cleanly stored, the model confidently invents something plausible, grounding the model in real retrieved text attacks, all 3 at once. Here's the whole architecture on one screen. Your question goes into a retriever, which searches a giant index of Wikipedia, 21 million little passages, and pulls back the top few that are most relevant. It finds them by meaning, not keywords, comparing dense vectors. Those passages, plus the original question, go into a generator, a sequence-to-sequence model, which writes the answer. 2 memories working together, the searchable index and the generator's own weights. And the whole pipeline, retriever and generator, is trained end-to-end. The clever part is how it uses those passages. It doesn't pick one, because nobody labeled which document is the right one. The training data never says use document 3. So instead, RAG treats the retrieved document as a latent variable and marginalizes over it. It runs the generator against all K passages and blends their answers, weighting each by how relevant the retriever thought that passage was. And here's the beautiful bit. That weighting is exactly what teaches the retriever what's worth fetching, purely from whether it helped the generator get the answer right. No retrieval labels needed, ever. Now the payoff that makes this special. Because the knowledge lives in a swappable index, not in the weights, you can update what the model knows by literally replacing the index, with no retraining at all. The authors proved it. Build one index from 2016 Wikipedia and one from 2018. Then ask about world leaders who changed in between. With the 2016 index, it answers 2016 leaders correctly. Hand it the 2018 index, and it answers 2018's. Same weights, different memory, different facts. Try that with a closed book model, and you'd be fine-tuning for a week. Quick one. If you like AI papers explained by hand, hit subscribe. New one every week. Okay, one more result, because it's the best one. This is the result I find most telling. Take the hard cases where the correct answer appears in none of the retrieved passages. An extractive system, one that can only copy a span, scores a flat 0 here. There's nothing to copy. RAG still gets about 12% of them right. How? Because the passages don't have to contain the answer. They only have to nudge the generator toward it, and then the generator's own memory finishes the job. Retrieval and generation covering for each other, exactly as designed. So that's RAG, end-to-end. Encode the question, search a vector index for the top passages, treat the document as a latent variable and marginalize over it. Then generate the answer, grounded in real text and its own memory together. Trained with no retrieval labels and updatable by swapping the index. It became the blueprint for every documentation chatbot, enterprise search tool, and RAG stack you've seen since. That's my read. Tell me yours.